Okay, in talking to several students, I came to the realization that some of you are struggling with writing the equation for a writing the equation for a function based on a graph. So I thought I'd make a quick video for you to help you through that process. Although many students might be perfectly comfortable just using some logic to help them get from this graph, understanding the phase shifts, into their actual equation. Some others needed something a little more concrete. So hopefully this will be helpful for you. Okay, in order to jump into this idea down here, we need to understand a separate idea first, and that's that we can factor out this period change, and it actually allows us to see separately our phase shift. Although we didn't do this when we were writing our own graphs, it's certainly an option. So if I factor out that 3, I can rewrite this equation as such. What that allows me to see is that I know I will still use this 3 to impact my period change, but it also allows me to immediately identify what my phase shift should be. This is going to be particularly helpful to write our own equations. This is also the form that they will use on the midterm and final because it's a simpler method if you're trying to work backwards. So this is the form I'm going to use to work on our graph down here. What we're going to do is we're going to write the equation for this graph actually 3 different ways. The first and simplest one is to write just a basic sine curve, recognizing that it crosses the x-axis right there at 0, 0, and I can visualize that it's going to continue going on and on. So I can see this as a reflected sine curve with an amplitude of 4. So I'm going to write y equals -4 sine. Now, before I can continue on, I need to understand my period. So if I look at this graph from start to finish, I can see that my period is 2 pi over 6, or in other words, pi over 3. What most students are already comfortable with is understanding how to get this coefficient that should go here by taking 2 pi, in this case times the reciprocal, 3 over pi. Of course, our pi's will cancel and gives us a coefficient of 6. So I could, in its simplest form, write the equation for this graph as -4 sine of 6x. I can also visualize this graph as shifted back, and instead of seeing it as a reflected sine curve, I can see it as a non-reflected sine curve that's been shifted back. So much of this will stay the same. I will still have the 4, but this time it's not negative. Still have the sine, and I'll still have the 6 because my period is still consistent of what I had before. But now I'm going to use my new notation to indicate my phase shift. So what I can see is that this graph has gone, if I moved this and I could move it all in this direction, instead it would look like the parent graph. So now what I can see is my parent graph has been moved a -pi over 6. So when I enter it here, I need to do minus the negative or plus pi over 6. And this is how you'll see it on your midterm or final. What you're accustomed to seeing up until now has the 6 distributed in, and it looks more like this. Lastly, I can look at the same graph as a cosine curve instead. Now, instead of visualizing this point right here as having been moved back, I'm going to focus on this point. If this were my cosine curve, remember this continues on, this point I can see has actually been moved back a -pi over 12. So this one has a phase shift of a -pi over 12. I'm always picturing what was the original behavior around the y-axis and how has it moved left or right. So the rest of this is going to be very similar. It starts up for my cosine. When I picture that moved back, it's still up, so there's no reflection. But it does have that amplitude of 4, so I have my 4 cosine. I still have my 6 because the period hasn't changed. And now my phase shift, I have that separated out, so x plus pi over 12. Again, that's how you will see these on the midterm and the final. The way you're accustomed to seeing them up until now looks more like this, 6x plus pi over 2, with that actually distributed in. Okay, I've also created a tangent graph, which of course you might want to pause this and jot this down. On the top here, just as a little reminder, just to carry this over from the previous page, we can separate out the period change from the phase shift again. And that's just going to make it a little bit easier for us to read and to work backwards. Again, it's not a requirement. If you're already comfortable working backwards without using this form, you are welcome to. So now, it's a tangent graph. As I mentioned for the previous page, we're always thinking about the behavior around 0, 0. And what I can see is that the curve that I have here right now already looks like a tangent graph. There's no reflection. It's nice and positive. It passes through 0, 0, just like my parent graph does. So that part's going to stay the same. I can also go ahead and pick out my period. And I can see that the period for this tangent graph is 2 pi. Remember, when we work backwards for tangent, we're comparing my new period to the parent period of pi. So now my coefficient will become a 1/2. The other thing that I can notice is that at halfway between, because that's a negative pi over 2, at halfway between these two values, I've been given this value of -3. That tells me that when I go ahead and I write my equation, I'm going to have a 3 as my coefficient, my tangent, my 1/2, and I can simply write the x because, again, there was no phase shift. Always thinking how it compares to the parent. So this one is pretty straightforward. As a cotangent graph, we're going to see a little bit more happening here. First of all, our parent cotangent graph would normally come down. So immediately what I know is that there is a reflection. Next, when I think about cotangent's behavior around the y-axis, what I would normally see right here is an asymptote. But instead of having my asymptote at 0, 0, I can see that my asymptote has been moved back pi. So this graph has a phase shift of a -pi. The period's still going to be the same. That's not changing for me. So I can go ahead now and jump into my equation. I have a reflection. The amplitude, although we don't usually necessarily have to call it an amplitude for tangent and cotangent, is still 3. I can write my cotangent. I've already identified my coefficient of 1/2 for my period change. My phase shift was left, so I'm going to write a plus pi, and then I'm all done. So I also could write -3 cotangent 1/2 x plus pi over 2. Certainly another option, but again, the answers in the boxes are what you would see on your midterm and your final.